All right, thank you for joining us today. So you're here for managing peak loads and renewables in CEA by Resource Innovation Institute with PG&E as our partner. Mary, you want to take it away for some of the safety stuff?
Certainly, this is a disclaimer. Please take a second to read this. It is just saying we believe we are accurately describing the technologies that we are presenting and that they are meant to clarify and illustrate typical situations. And you would need to apply the information with your own expertise to your own individual circumstances. Next slide. Also, while we're not taking images of anybody, but if you do ask a question or we somehow capture your image, sound, voice, or your questions, these can be used in our future promotional materials and recorded sessions. Next. And here's a very quick safety message. In the case of an earthquake, drop, cover, and hold. It's important to have an evacuation plan. You need to know where to meet your coworkers, your family, so you know if everybody's accounted for, and you can let emergency response folks know if anybody's missing. And a lot of times there is cause for an emergency evacuation. So do please plan for an emergency and pack a go bag, which includes all of your essentials. And then most importantly for today, stretch, get up, and move for good ergonomics. Next. All right, this is an important feature. We do like your feedback because we always like to improve our classes. Towards the end of the class, I'll put a survey link in the chat box. We love your written comments and this other topics and other classes you want. This is really important because we are just one class away from our planned end of series for this CEA classes. And if you want more topics, if you think things would be particularly important for you, this is a really good chance for you to tell us what you'd like to see as we do future class preparation. We'll also send you a link in the follow-up email after class. Next.
Great,
Now
thanks,
it's
Mary.
to you.
Yeah, thank you, Mary. All right, so with our introduction, I'm launching our first poll. So these are polls for you, the audience right now. And as we go through, this will help us understand who you are so that we can cater what we are talking about towards you and what it is that's important to you. So we appreciate you answering that poll. And then at the end of each kind of section, we'll talk about the results a little bit. So our agenda today, we're talking a little bit about our introduction and then Energy Management 101. Why are we talking about this? Why is this important? Planning and management, on-site energy solutions, and then utility and state programs, a quick tips and tools, and a Q&A. So today's experts, I'm Carmen Azzaretti. I'm from the Resource Innovation Institute. My background is in mechanical engineering with a focus on energy and buildings. And then Sultan Sabha, you want to introduce yourself?
Yeah, thanks, Carmen. Good afternoon, everyone, and thank you for joining us today. I'm Sultan Sabha with our Comeri Power Solution team, where I work mostly in commercial solar projects from design to installation and commissioning. My work also involves incentive studies, energy studies as well, and I have been involved in different types of solar systems, such as grid tied, off-grid, battery storage, roof mount, ground mount, you name it. And I'm joined here today with my colleague Sam from the ACE team.
Thanks, Sultan. Hello, everyone. My name is Sam Schmidt. I am a commissioning project manager at ARCO Murray. I'm a licensed professional engineer for HVAC&R in Illinois. However, I've performed new construction commissioning as well as existing building commissioning throughout the United States. So part of my commissioning efforts, I work with the utility providers and try and leverage incentives when performing energy efficiency upgrades. So I'm excited to be on this panel today and be joined with PG&E.
Yeah, thanks, Sam and Sultan. So throughout the workshop, as you have questions, drop them into our Q&A. And then towards the end, we'll be circling back and answering some of your questions. So if you have any questions for Sultan or Sam, as well as our two PG&E representatives, Mary and Scott. So Mary McDonald, do you want to introduce yourself?
Oops, sure. I am Mary McDonald. I work in workforce education and training at PG&E, we provide free energy efficiency classes, and I head up the track for our agricultural classes, which this is part of. And as I said before, always looking for more topics to add. I also run our tool lending library, which loans energy measurement tools to California ratepayers for free, and we'll tell you a little bit more about that later in the presentation.
And Scott Bond, you want to introduce yourself?
Yeah, absolutely. And I'm Scott Bond. I'm a PG&E account manager. Been with the company for about 15 years. I am part of the ag and food processing team, and I lead up the CEA segment, which kind of helps the company as a whole focus on this segment and see what we could do to help improve interactions with and support your industry. And while if you have I'm going to throw a plug in for your account manager. If you don't have an assigned one, please reach out and we'll throw some numbers up there to an account manager, and they can help you navigate all things PG&E. Please lean on us because that's what we're here for.
Yeah.
Carmen.
Thanks, Scott. So we'll talk a little bit more about what PG&E has to offer towards the tail end of the class and circle back with them. But any questions you have for them, feel free to ask them in the Q&A as well, and we'll circle back on those. So this is not where the learning ends. So you have a California virtual classroom available to you that has recordings of all the live workshops from this series with PG&E, as well as the series that we did previously with SCE. So tip clips, downloadable resources, links to the state programs and tools. Go here, learn more. We can't cover everything today, obviously. So make sure you check out your virtual classroom and register for any upcoming workshops. So we have 2 upcoming workshops. There's the case studies in efficiency that will be on May 2nd, as well as a PG&E hosted workshop in the code breaker kind of branding directly through PG&E for controlled environment horticulture and the energy code. So check those out, go in and register. Then let's see what people said. So for the what role do you play in the cultivation space, it looks like we mainly have consultants, and I probably should have had another answer because there's a whole bunch of others as well. But now we're going to go and talk a little bit about energy management. So we'll start with how comfortable are you reading and understanding your energy bills? So this will be kind of important as we go through this section to talk about what are energy bills. But quickly, the California cannabis space, so there's a handful of different license types. The market size is about a $4 billion legal market with another $8 billion illicit market on top of that. We mainly talk about indoor, greenhouse, or mixed site, but outdoor folks can also benefit from this kind of group, as well as folks who might do kind of a mixed space with some greenhouse and some outdoor. There's a handful of different lighting types out there. But why are we talking about energy in cannabis? Well, California has some of the most expensive energy in the country. If you look at this first chart of cost of energy by state, this is all the 2021 numbers, but this is all government data, and California has some of the more expensive energy in the country. So California producers are going to be spending a bit more on energy than a lot of other producers in other states. But if we look towards the global warming potential, California is actually doing really well. But when you plug in and use energy from the wall in any state, it's not all the same. You don't have the same carbon emissions with each piece of energy you're using. So it's important to think about when we're using energy and where we're using energy because the emissions are not always the same. So for a cannabis producer who wants to save money on their energy bills, it's really important to think about energy in cannabis. And for a prep producer who really wants to reduce their carbon footprint and green up their product, it's important to think about that energy consumption and to really understand what the makeup is of the energy that you specifically are using when you are using it. So if we look at the bottom here, one of the other things we're going to talk about is kind of the importance of order. So starting with conservation, making sure that you have appropriate energy use practices, and then investing in energy efficient equipment, and then load shifting, and then renewables. So, throwing solar panels up there is great and all, but if you're leaving all the windows open all the time, that's probably not going to help you. So as we go through, we're going to highlight what section specifically we're talking about in this, but this is the order of operations we want to flow in. Conserving energy, investing in good equipment, considering when you're using the energy, and then investing in renewable equipment. So quickly, here are a handful of these definitions of loading that we're going to talk about. So what we were talking about was loading order. So how often we're doing or what order we're doing those things in, but all these different types of load can help you understand as we talk about energy bills, as we talk about energy, kind of what that means. And this will be available, this deck, after the workshop as well. So when you're trying to remember what we're talking about, it's there. One of the important things we're going to talk about today is right there in the middle. It's called peak load. So it's the highest amount of energy a consumer draws from the grid in a set period of time. So if we keep that in mind, kind of as we go through, it can help you understand some of the other pieces. Now I'm going to hand it over to Scott real quick to talk a little bit about reading your bills and understanding your electric charges for PG&E specifically.
Thanks, Carmen. Yeah, I'm just going to very briefly talk about some of the key components of the electric bill. And then further on down in the presentation, we'll dive in a little bit more. But here are the three common or key components that we need to keep in mind when we're talking about energy charges, and that's your demand charges, your energy charges, and time of use. So your demand charges kind of generally cover those fixed costs for generation, transmission, distribution, and so forth. We speak of these in kilowatts or kW. Energy charges covering the variable costs, more or less, the power that's consumed. And we just talk about this in terms of kilowatt hour or kWh. And then last is time of use. And this is a really key component to electric charges. It kind of reflects the system conditions at a given given season, time of day, and significantly over the last few decades, really, has been impacted by the increase in grid scale solar. So we're going to talk about that a little bit more later in the presentation.
Thanks, Scott. All right, so wrapping up this poll, it looks like most folks feel very comfortable reading their energy bill who replied, as well as a good number of people thinking that they understand them and feeling, relatively confident. So it sounds like we have a group of folks in here today who are pretty confident understanding their energy bills, and it's going to kind of help us take the next step. So if we had people who are mostly really uncomfortable, we might be speaking at a little bit more of a basic level, but now we know that most of the folks in this room are feeling pretty comfortable reading those. So I'm going to hand it over to our ARCO team, starting with Sultan, to talk about planning and management. But let's kick it off with a control system question. Now, this can help you kind of refine your energy consumption and energy use. And Sultan will talk a little bit more about that. And that's kind of why it's important. But here on out, Sultan.
Yep. Thanks, Carmen. So yeah, I just would like to see, looking forward to see what control system the audience uses. And then I will start to kick off the planning and management section. It is important to start by determining your goal, and in order to plan ahead in the right way when it comes to energy and consumption, first we need to understand the type of facility we are working with and the type of spaces within this building or facility. Since we are here to talk about energy and peak load, understanding the type of these facilities will help us understand and predict our energy consumption to assist in reducing peak loads and selecting an efficient power solution. So for this presentation, we will be touching on our generic approach of how to understand your energy needs to select your best on-site power solution. And we will be focusing more on controlled agriculture facilities in which they are unique and generally have high power demands than what a utility or a client may be used to seeing. It is important to understand that it's important to understand that the power that your facility requires, and it's also important to understand your power rates, and this will help you know your grid capacity to guide you on how you should plan in using and managing your facility. I will let Sam to add more points on how to understand your building energy requirements.
Sure. Yeah, just briefly looking at all the different types of spaces is important to understand how you're going to use your facility as a whole, right? So controlled environment agriculture facilities, start with cultivation, but many times include processing, packaging, storage, and warehousing, right? So understanding each room type will allow you to create maybe an energy goal and control requirements for each area. So breaking down your facility into room types will allow you to better understand the building as a whole.
Cool, thanks, Sam. Another thing we need to look at when Yeah, thank you. Another thing we need to look at when trying to understand the energy consumption is if the building is a retrofit or a new build. Carmen, can you go back to the previous slide, please? Yep. So for existing facilities, we need to look and see if we have utility bills, right? This will be an ideal case in which the bills will give us exact energy consumption of the facility and will let us see how we can increase the efficiency of our facility and how we can shift our loads to reduce our own peak demand, and finally know if a renewable option, such as, let's say, solar, is reasonable, right? And that will be based on if your energy consumption is mostly during the day, so you can use that solar energy to directly offset some of the energy demand during the day. And then for new build, which might be the case, first we try to understand the consumption by comparing it to an existing facility with the same energy usage. You know, you want to have a facility that has the same equipment, mechanically or electrical equipment, and try to size that facility to your current facility that you're trying to study. Another way which what commonly used at our Comeri Power Solution AMPS is the 8760 load profile that we can obtain through our energy app. And I'll be talking about that now in this slide. So when talking about greenhouses and grow farms, modeling the operation of your facility can be extensive. The equipment and processes all interrelate and react to different factors: growth and harvest schedules, solar gain, temperature, humidity, and many other factors. The interrelation requires that you view your facility needs on an hourly basis, and that's where 8760 comes in handy. So you have 365 days a year, 24 hours. This is where you get your 8760 load profile. Knowing your hourly demand, you can now understand your consumption. By doing so, you can also find a way to shift your load in order to reduce the peak demand and shift your equipment load schedule to your off-peak hours. Moving on to the next slide. And the 8760, to summarize, it will help you understand your power needs by predicting your consumption and presenting your hourly energy usage and behavior, which ultimately helps you predict your energy OPEX, provides data to the utility to help understand if there's enough capacity to interconnect to the grid, and it helps to understand your energy demands. It also helps in sizing your power generation system and give insights on alternative energy generation. Now moving on to the 8760 load profile and rate structure. Another thing we take into account when generating our 8760 energy study is incorporating the utility rate based on the location and utility provider info. So utility rates are not constant and can have large fluctuations in prices, especially related to peak demand. Each utility is different in their rate structure. Your peak usage defines your rate group, which sets your rate structure. Applying the rate structure to the 8760 will result in an accurate estimate of your electric bill and will be a great start to exploring your energy procurement options. I will let Scott from PG&E to chime in here and discuss the rate structure, and then Sam will take it over and talk about energy management.
Great, thanks, Sultan. Could you go back one more slide there, Carmen? And I just wanted to share two examples of rate schedules that you'll see in the CEA world. The first being ag, the second being the mid-size industrial commercial rates. And it's complex. There's no way to get around it, and more reason to understand it, to dive in. Go to pge.com, your account, and examine your usage, your bills. And if you have any, well, it looks like most of you are really familiar with your bills. If you have any questions, reach out to your account manager, and we could do our best to help you understand it. I won't delve into the details on this, so let's go to the next slide there, Carmen. And this will show, I'm sure you've all heard, a couple of years ago, we switched our time of use periods. Historically, summer has been 6 months, and peak hours happen 5 days a week, not 7, and so forth. So what we've done in response, largely due to the amount of solar that's providing electricity to the grid, is we've changed it and shifted the peak hours from noon to 6 to either 4 to 9 or 5 to 8, depending on the rate. Summer is now 4 months, not 6, and so forth. So make sure you understand what your time of use periods are, whether they're the commercial industrial, the B19, the B10, B20, or the ag. Ag is much more simple these days and poses a great opportunity to avoid peak demand charges because it's only 3 hours a day. So again, if you want to figure out how to optimize your operation to minimize your costs, reach out to your account manager, and we'll do the best we can to educate you and work with you on that opportunity. Back to you, Carmen. Actually, back to Sam.
To me. Thanks, Scott. Yeah, so jumping in here to strategic energy management, right? So we want to put forth a strategic energy management plan. That's the recommended approach to consider all things energy for your facility, right? So that begins with conservation, as Carmen had mentioned earlier, right? Creating a culture of conservation is paramount. Like Carmen said, if you don't use the energy, then there's no need to be efficient with it, right? The best case to reduce energy is to use less of it. So conservation is first and foremost, and there are programs available to try and spread that education and that awareness. As Scott mentioned, PG&E is willing to help, and every other utility provider that you would have would do the same, right? So, creating a culture and a process that enforces conservation is really the first step in energy management. The next step, jumping to the next slide here, is understanding where your energy is being used. So this little pie chart on the right is something that we call an end-use breakdown, right? So it breaks down your total electricity usage, in this case electricity, into each sort of category or type of use, right? So the chart on the left is from Evergreen Economics. It was a study funded by SDG&E, but they determined that lighting is about 38% of the electricity usage in an indoor cultivation facility. So understanding where your usage is will help prioritize where to invest and what are the best areas to improve efficiency to yield the most gain in terms of energy reduction and also cost savings, right? So lighting may seem like it's the most, but if you look at those next two, it's ventilating, it's dehumidification, it's air conditioning, right? If we combine those all together, that's about 50% of your electricity usage. So being aware of where your energy is being consumed will arm you with the right information on where to focus your energy efficiency improvements to yield the best results. The next thing I want to touch on this slide is looking at your energy consumption in terms of metrics. Can you jump back real quick, Carmen? Just looking at your yield in terms of a kilowatt hour or your yield in terms of square footage, right? And then comparing that kilowatt hours to square footage as well is a way to create a baseline, a reference point, right? And so then you can almost compare each harvest cycle to the previous harvest cycle. How well did we do in terms of yield? How well did we do in terms of power consumption, right? By creating these metrics or key performance indicators, some will call them KPIs, you can hold yourself honest and keep yourself to your goals, right? And even set goals, right? So creating a baseline is a way to make sure through data, you're able to maintain your goals and hit your energy targets. So quick plug there to benchmark. RII has a great tool called Power Score, and it will assist with some of these energy consumption metrics and benchmark your facility. So from conservation, creating that culture of conservation, and now identifying areas to focus our energy efficiency, I'd like to touch real quick here on energy efficiency investments, right? So starting at the top, LED horticultural lighting is definitely something to consider if you have an existing building with metal halide or HPS lighting. LED fixtures are a great method of improving your energy efficiency. There's also something to be said about integrated HVAC systems that have a chill water system and a hot water system, right? As you grow and scale your cultivation facility, there's a tipping point where a packaged HVAC system may not make sense, and it may be more efficient to use a chill water system and a hot water system. There are other items on this list here to consider, right? Heat recovery chillers are a great option when you have that 4-pipe system in place. Another method would be heat exchangers, right? So using your return air to sort of preheat after you dehumidify is a method of transferring air and reusing heat. So these are all great items here, right? Energy curtains in a greenhouse, things to consider when approaching energy efficiency from an investment standpoint, right? So from new construction, these are definitely great items to consider. In an existing building, when you're approaching end of life on some of your equipment, right? Again, another place to come look at replacements. And then, lastly, to plug PG&E and some incentives, right? When you're looking at your facility and how can you improve investment, your efficiency, right? Always keep in mind that there are incentives on the table that can help you with the capital expense from these investments, right? So then jumping onto the next slide, right, carrying through our little green arrows at the bottom, we're going to touch on load shifting here, right? So these would be cost-saving investments rather than energy efficiency investments, because you're not going to be reducing your energy usage, but you'll be shifting when you use that energy. And as Scott touched on, with time of use pricing and peak demand having a different rate on peak versus off peak, it can be valuable to shift your loads off peak in terms of cost, right? So a few methods to do this outlined on this slide here. And having an integrated control system is a great way to allow you to implement those different programs to allow you to shift your loads, right? So staggering a room startup, there's a little chart on the side there. Operating rooms on a flip schedule. If you have 2 rooms on rather than 1 on and 1 in a night cycle, and then you flip those, right, your peak demand would accumulate with both rooms being on. Whereas if you operate on that flip schedule, your peak demand is just going to be the 1 room on. So that's, quick snippet, but you can see how staggering your rooms can quickly shift your peak load. I touched on a 4-pipe hydronic system, right? So, one method is using thermal storage and generating chilled water, maybe in an ice storage overnight, to then shift your chilled water usage from daytime to nighttime to shift that usage away from those peak demand charges. And that's a great way to have some cost savings. But again, isn't reducing your energy consumption. Lastly here, I want to touch on building automation systems, as it was our poll question. And it's ultimately the tool that's going to allow you to program in changes and shifts. So if we could jump to the next slide real quick, Carmen. I'll walk down this not too exhaustively. It's a lot of words. That first bullet and all the sub bullets come from ASHRAE Guideline 36. It is the high performance sequences of operation for HVAC systems. It's a great resource to make sure that when you're programming your building automation system, that you're doing it efficiently. And so I just want a quick plug for that. And it also is, it meets Title 24 Energy Code. So a building automation system can allow you, right, to shift your operating schedules and program in changes, right? If you want to do a night airflow setback, that is a method of reducing your energy at night, and can be achieved just through a building automation system on your computer, right? So investing in a building automation system can unlock some of these control strategies that really will improve your energy efficiency. On top of that, we can touch on fault detection and diagnostics, right? Continuously monitoring your system, right? We go back to metrics and KPIs and identifying, hey, last month we're using more energy than we did last month. We should look into this, right? So, monitoring-based commissioning comes into play for that case, right? To continuously monitor your usage and your consumption, identify anomalies so that you can investigate into your facilities and identify something went wrong here or something's not operating as it should be, right? So all great things to consider, and a building automation system is the tool that's going to allow you to shift your load and operate efficiently. So let's see what the results are. Looks great. CO2 controls, lighting controls, most of the things we would expect. A little less on the water treatment plant, and I think that's more than normal. But no, that's great results.
Cool. Thanks, Sam. And now we'll move on to on-site energy solution. So let's start with answering this question. What do you guys think is the most efficient on-site energy production method? We'll discuss the results at the end of this section. Cool. Okay. So there are different types of on-site power solutions. In this section, We'll touch on solar, battery, CHP, and microgrids. So again, referring back to planning and management, the first thing is that you need to understand your goals in using these power solutions. Are you planning on offsetting your energy with a renewable source? You want to go green, or your goal is shaving your peak demand, reducing your electric bill. In the selection process of your power solution, you would need to understand that there are different factors and variables you want to look at. For example, the climate you are in. Does it make sense to have solar? Is it sunny enough, right? Is there incentives available? What utility programs are available for different power options? This will help in narrowing down your options and help you decide which solution makes more sense to use and utilize. So in the next slide, I'll be talking about solar and CHP, as this is AMP's expertise. So for solar, now in California, Title 24, as of the start of 2023, requires all new buildings to have solar and battery, and that is based on your conditioned floor area or the SARA, which is the solar access roof area. And part of planning and management is that you need to plan ahead when it comes to solar. You need to make sure your roof can structurally withstand the dead load and lateral load added from the solar system. And you want to make sure your electrical infrastructure can interconnect the solar system. Per NEC, National Electric Code, if you are planning on having a load side connection, you'll be limited to 20% of your service size. If you want to have you want to have more solar, let's say, you don't want to be limited by your service size. So you can have an interconnection to the supply side of your service. So this might be easier for new construction, where you can have a section added to your service and the supply side. So to summarize, basically, you want to plan ahead and weigh your options. For an existing building, you need to see if you need infrastructure upgrade. For a new build, you can incorporate those to the design and make sure you check those requirements before deciding on having solar. Again, so solar can be grid tied, front of meter, behind the meter, supply side, load side connection. It can be off the grid. It can be connected to a battery system. So now let's talk more about battery, right? So for battery storage, when does it make sense to have a battery system? So I want to touch on something called net metering, which is basically when you have an excess energy feeding back to the grid, you'll be selling it back to a certain rate. So if you have a net metering of 1-to-1 ratio, meaning that whatever price you pay to get this electricity, you'll be getting it back when you feed back to the grid, basically selling it back for the same ratio. I would say it does not make sense to have a battery system, because technically the grid is your battery, right? Whatever excess energy you have, you can feed it back to the grid and get credit for it. But now in California, with the implementation of NEM 3.0, Net Energy Metering 3.0, this is causing metering now to reduce 75%, which makes more sense to have a battery system. It makes it more attractive. It helps with your ROI, makes it look more as a better investment. You can store the excess energy to your battery and use it during your own peak hours. The other thing I want to touch on is CHP. CHP can be connected similar to solar. It can be off the grid and it can be grid tied. CHP is a great source of energy, especially when you utilize that excess heat to your HVAC. When adding a CHP, you want to look at some variables that impact what functions you want from that excess heat from the CHP, let's say. So for example, I'm just going to put an example here. Let's say you're in the Midwest. It makes sense to use the excess heat to your heating, right? Other usages for use CHP can be a boiler, or you can have an absorbent chiller attached to it. In California, let's say, you can use CHP as well in the colder days during the night for heating, and you can also use the excess CO2 for your crop. You can recycle that CO2 and filter it and reuse it for your crop. So when selecting a CHP system, it is important to coordinate with your HVAC system to leverage that waste heat available to maximize your efficiency. Now moving on to the next slide. So we want to talk about preparedness here. Let's talk about power outages and how you can have a solution for this power outage. There's multiple solutions you can look into. You can look at generators. You can look at CHP as a backup. You can look at battery as a backup. And then what is important here is to understand how you want to size these power options. So this will be determined based on your goals of the facility, right? Are you trying to offset your entire facility when there's an outage, or you're trying to offset your critical loads of the facility? So you need to define your main components of the facility that needs to be, this needs to be part of your planning. You also want to know your backup duration so you can size your backup solution correctly. I would like to mention that PG&E have some programs for generators and batteries that we'll be talking about in the utility and state program section later on. And I will let Sam here to talk briefly about microgrid, as he's a controls expert. Sam, you're muted.
Thanks, Sultan. Sorry about that.
Nice.
Yeah, just real quick, a microgrid, it manages your on-site loads, right? So it'll continuously monitor your building demand in order to prioritize your energy generation equipment to meet that building demand. Your microgrid can also be used to enable a generator and therefore provide some grid stability for your microgrid that you operate on.
Cool. Thanks, Sam. And one more thing I want to touch on is something that is called redundancy. It's also important to know that sometimes your backup option is not working, let's say. So you can have another CHP. Let's say your backup is a CHP. You can have another CHP on site that is backing up your CHP, and that's called redundancy. It's a good solution once you want to avoid system failure that is commonly used. I just wanted to touch on that. And then finally, I would like to talk about financial analysis, or, this is the last thing I would like to touch on, and it's important to look at your power solution as an investment. We as a design builders are here to help and evaluate different power options and show how adding this power solution can be a good investment in which power option and which power option makes more sense based on your different goals. Are you aiming for a good ROI and payback period? Does this system needs more infrastructure upgrades? How does that look like in terms of, adding this power solution to your facility, to your site, and which one makes more sense based on your goals? And now we'll move on to see your answers for the first question we had for this section. So most of you got a right answer. Probably people selected solar and battery because there is a battery here, but I think the intent here was just solar by itself. Solar is, now ranging around 22%. CHP is between 60 and 80, most commonly 75%, and wind is 40%. So CHP will be the winner here. And then we'll move it to PG&E and the utility and state programs.
I'll introduce the poll alert. And this is about one of the tools that we have available to all of our customers at PG&E.com. It's called Your Account. And so the poll question is simply, have you used it? And we've got 3 answers for you to choose from. So please fill out that poll. We'll move on to we've got an array of programs through PG&E. I'm going to talk briefly about demand response programs. So demand response is, they are a series of programs that provide incentives to customers to reduce the amount of electricity that you use during, typically they're heat events, but there might be other grid related issues or emergencies that cause us to call a demand response event. I've listed 4 of the benefits that come from demand response. And we've got an array of programs from low risk, low reward to high risk, high reward, and a few in between. We have programs through PG&E Core, and we have third-party providers that work with us to provide additional programs. So again, a broken record, reach out to your account manager and discuss your operation and see if you can find a program that that would be a good fit. Our latest program that we introduced is called Emergency Load Reduction Program, ELRP. It was developed, to help during those grid stability events that typically happen during heat waves. What we like about this program is it's got a reasonable reward, $2 per kilowatt hour, but there's no risk, no penalty at all. So it's a great program that you can use to kind of dip your feet into the water and test demand response. Again, work with your account manager or an account manager to identify the program that best meets your needs. Now, many customers assume that they can't participate in demand response. I'm a food producer. I've got perishable product. When it's hot, it's really key for me to keep everything running. But you might be surprised that there are opportunities at your site. And so what I'd like to do now is introduce Anthony from Bonita Produce down in Santa Maria. They are a refrigerated warehouse focusing on produce. Now you might ask, why are we talking about this, about them, refrigerated warehouse? We're a CEA segment. The reason that we introduced or asked Anthony to come is because they had that same initial reluctance to demand response that a lot of customers have, yet they explored it and they're currently a successful participant in demand response. So I'm going to ask Anthony to give us a brief explanation of kind of their path down the DR road and see how they explored it and succeeded with it. So Anthony, I'm going to let you take it from here, and I'll reach out if I have any questions or follow up.
Hello, Scott. Thank you so much for having me on here. I'm glad that PG&E actually has incentives for us to get rebates back. The energy that company that I was working with would be Voltis, because I'm a big on energy savings, because that's definitely going to help us out, in the long run, while saving money for the company. First of all, when I reached out to Voltis, I wanted to get the most out of it. So they explained to me, what they had going for the demand hours. So it was 2 hours out of the month between the months of June through September. Out of the month, it was only 124. It's going to give you a 24-hour notice, and only shut down for 2 hours. The nice thing about Voltis is they actually have a dashboard that you can actually see your energy in real time. This gives you all the information that you're actually needing to trim down the equipment that you actually have. And that's what we ended up doing. So we ended up trimming down a lot of our equipment, shutting down evaporator motors. There might be only a 1.5 horsepower motor, but in reality, since we have over 100 of them, that puts us at about 144 horsepower just on motors alone. And reducing that was able to reduce the capacity of the compressor, so which entailed we were able to do a savings along with them. And the only thing that I actually needed help with was from everybody on each department, meaning that, closing the doors, making sure they're not going in and out, in the staging areas. Items like that actually helped out with the energy savings. We ended up getting back $17,140 just for the 4 months that we participated, and we only shut down once out of the month for the 2 hours. We did hit the heat wave last year, which ended up we ended up participating a little bit more, because the fact is, like I was saying, on a dashboard that actually shows you in real time on what you can actually shut down without affecting any of your production or anything of the production that is moving forward for no loss of time. So that helps out in a great deal. But the whole goal is to save money, and that's the main thing. We're all trying to save the company money, and that's what our main goal was to achieve.
Great. What was the reception like when you first presented demand response to upper management, to the operators, technicians? How did they respond initially?
The first thing when, as far as the upper management, the first thing that they're saying, no, we can't shut nothing down. This is impossible. We can't do it. And, you know, but they gave me that time to, I said, let's just try it and see what we can shut down. Right now we're able to shut down up to 350 kilowatt hours, which is a great deal. But it came through some practice. You know,
Right.
what motors we could shut down, stuff like that. You know, what's not going to hurt us. You know, like say we have an evaporator and it runs two fans. Well, can we get away with just shutting off one fan and then leaving the other one running? So little bit of a playing around here and there actually helped out, because you're still circulating the airflow of what you want to do, but yet you're reducing the power demand.
Right. Now, didn't you identify some opportunities that enabled you to participate in demand response, but also had impact the rest of the year?
It definitely impacted. Well, I mean, it helped out for the rest of the year as far as that's concerned, because now I don't have to, I can actually shut down certain areas and still maintain energy savings that way.
Perfect. Fantastic. Great. Anthony, hey, thanks a million for sharing your story. Appreciate that. And
Thank you.
if you have questions for me or Anthony, we'll try to pick them up during the panel discussion afterwards, or I'll try to monitor the chat and Q&A and see if I can answer any of them. So with that, I'm going to pass the mic back to Mary, who's going to talk about more of our programs, more of our incentives, starting with the self-generation incentive program. Mary.
Yeah, and I'm really thrilled that we have a lot of opportunities for you to save money, get incentives if you implement some of the strategies that we've talked about today. And the self-generation incentive program, again, we encourage people to install batteries through this program. It helps reduce greenhouse gas production, and it supports our grid. We also incentivize using generation technologies, including thermal and mechanical storage, wind, fuel cells, internal combustion engines, microturbines, a pressure reduction turbine, or a linear generator. So next page, next slide. This is, again, a little bit more about why storage and backup power is good, including the fact that you can discharge the battery during peak hours to reduce your bill, and then charge it during the lower cost periods. If you do, our commercial customers can qualify for the large scale storage incentive, which is 25 cents a watt hour. And if you do implement generation, you can get $2 per watt, and you can get an additional $2.50 per watt if you have backup to the grid. For instance, if there's a public safety shut off or the like, and you're able to generate for yourself. So you would get up to $4.50 per watt for that generation. Next slide. Oh, just real quick, for that generation, if you do use a fuel, there's a requirement for 100% renewable fuel to be used. Now, next slide. All right. We also have a slightly smaller program where eligible customers can get a $300 rebate on the purchase of either a portable generator or a battery. There's additional rebates available, but those are for residents. So you must have an active residential or business account, and you must be located in a tier 2 or 3 high fire threat district. or served by an enhanced power safety setting protected circuit. That's a circuit where PG&E has installed switches so that when a fault is detected, they can turn off the power very quickly before causing a fire. And then your product must be on the qualified products list. So I did put the information there about how you can determine if you're in a high fire hazard severity zone, and there's no publicly information or available information about seeing if you're on the EPSS circuit, but you can email the address there. And on the next page, this is a map of fire hazard severity zones. So you can see where there's the red and the dark orange. Those are the zones where you're going to qualify for this program. So basically, if you're in the Central Valley, probably not. If you're on the outskirts of the valley, it's worth checking with the folks to see if you are in a high fire hazard severity zone. Next one. This one is about a backup transfer meter program. Say you have a bunch of batteries or a generator, and if your power supply is cut off, you might need to run extension cords and the like to keep powering your equipment. And this transfer meter is available free to our customers, and it actually will automatically transfer over to that backup power for you and then switch it back when the power comes back on. So if you are interested in something like that, you can contact PG&E at the website that we included there. Next slide. I just also wanted to tell you, I mentioned I work in workforce education and training, and we provide energy efficiency classes. These are 3 classes coming up if you want to learn more about PV and energy storage systems. These are all online webinars and offered for free. So go to pge.com/energy classes to find those. Next. So Scott, I'm going to let you do, Scott, maybe you can discuss these results. Okay, I'll go ahead.
Oh, there we go. Sorry about that, Mary.
There we go. Cool.
Yeah. Yeah, it looks like most people have not used it. So definitely, I want to put a plug in for that as well. It's a great tool to look at your billing information, your demand and energy usage information. You can use it to submit start-stop service requests. You could learn about outages. There's a plethora of information at your account, so worth at least exploring and taking a look at if you haven't. And it looks like most of you haven't. So please do. And it's good. And the reason I threw in that third question, accounts payable does, but I don't need to. I think we all as employees need to be accountable and aware of our energy charges and however we use it at our workplace. And I work with a lot of maintenance departments, maintenance and engineering groups, and they just say that. They say accounts payable pays the bill. We don't know anything about it. So please take it to heart and encourage you. I encourage you, and if you're a consultant, encourage your customers to take a look at it and own energy at the individual level, because that's the way we're going to change the culture and get people aware of and considering what they could do to minimize the amount of energy they use and ultimately the amount of money they spend on energy.
And Scott, I believe all of the accounts have a green button. And what you're able to do is you click that green button and you can download your interval data. I think it's an hour interval. I'm not positive for commercial accounts. So if you really want to understand your energy usage over time, you can download that data for a specified period that you request, and you can do your own graphs and analysis of it to really understand better when you're using data or when you're using your power.
Absolutely. That's a great point. Thanks, Mary. And this is the next question. I'll take it. I'll take it. How do you engage with a PG&E account manager? Some customers, the larger customers, have assigned account managers, and hopefully we have been reaching out to you. Medium and smaller size, we've got a pool of account managers that handle those customers, more on a reactive basis, but they're there to help too. So, do you need their help? Actually, you could read the answers. So please fill out the poll and answer, and that will give us a better idea of what you've been doing out there. So with that, I'll pass it back.
Okay. All right, I mentioned I run our tool lending library. We have over 5,000 tools that we store in San Ramon. I have solar tools where you can do shade analysis to help plan your PV system. We have lighting tools so you can evaluate the PAR and other aspects of your lighting. We also, a big thing here is related to this class is understanding your power loads and how they vary over time. But you may only have 1 meter at your site, but you have all sorts of equipment, and how would you figure out how much each piece of equipment is using? What can you shift? And if you can shift this chiller, how much will that shave my load at that time? So we have power loggers that you can use for disaggregating your loads. You would put those on individual circuits, and then you would have the data you need to understand how that power consumption varies over time, what your peak load is, and the like. We also will help you figure out, if you call us or email us with a question, we'll help you figure out what the best tools are for your project. And we'll troubleshoot those tools with you, and if need be. And we do provide you with app notes to explain their use. And if you are not comfortable with your data analysis, I can take your data and graph it in about 5 minutes to help you give a picture of what's going on. So I'm happy to help. So that's us at pge.com/tools. In Southern California, Edison has a similar library, but smaller. And so there is their website. Next. A lot of times if you're doing a retrofit or new construction, you need to apply for new or upgraded service. So this is just a very general description of how you would go about it. We'll go on to the next slide. And this is, so just as a general statement, we do provide energy efficiency engineering support, rebates, and incentives. Also on-bill financing, which is 0% loans to customers. And these come through the public purpose program funds from the California Public Utilities Commission. Each segment, we have a lot of third-party companies who actually run the programs. And for CEA, TRC manages it through their ASAP program. So next slide. ASAP here is their website. They do have rebates and incentives for grow lighting and controls, for heat curtains and IR film, which were mentioned earlier as an energy conservation or efficiency tool, boiler pipe insulation and heat recovery, irrigation upgrades, and more, as it says there. These are either deemed, meaning you just purchase a product and you get back your rebate, or they're custom based on the amount of energy that is saved. So next slide. This is just a little bit for the deemed. You purchase your equipment, you submit an application, and once that's reviewed, you get your rebate issued. Next, and that's pretty fast, 1 to 2 months. A slower process is the custom incentive process, where you have to assess and then you apply. What you're assessing is how you're estimating how much energy you'll be able to save, and this sometimes takes a baseline power study. So then you apply. Once it's approved, you install. Then you have to verify it with monitoring. And then based on the verified savings, you get your incentive. And this can be 5 months and longer. There's a little bit about on-bill financing. And I would say if you want to look more into that, you can contact ASAP or your account rep. Next. The market access program has particularly higher incentives right now. This is a limited time availability, but they do support energy saving and load shift projects that must be installed by March 31st, 2024. Go ahead, next page, please. Your lighting will this would be a good place to go if you're looking for a lighting rebate, because under ASAP, it's still a custom process. And so it's going to take you a little bit longer and a little more effort. This one is a little faster and easier to apply for lighting and other rebates. Next slide. Here it is. Just remember, projects must be installed by March 31st, and you can learn about it at the website provided there, or contact Tyra Adams, the project manager, at the information that is provided. You'll get these slides, so I'm not going through every little detail on the slides. Next. There are certain statewide programs for the California Energy Design and Assistance. This is free or complimentary services for new construction, helping you find energy efficiency opportunities and design. And then the California Department of Tax and Fee Administration also has some equipment exemptions under their agricultural programs. Next, there we go.
All right, thanks, Mary. It looks like there is kind of a little bit of a split here between people who didn't know their account managers could help, as well as people who are already working or don't feel that they need their account manager. So here we have just a couple actionable takeaways that people could think about. And again, on that bottom piece, we have that priority of your energy efficiency. And we're going to flow right into Q&A. Now, there's been a bit of answering questions throughout. So, check out the Q&A and see if your question has already been answered. But I do want to talk a little bit about the 8760 model. So, Sam or Sultan, can you expand a little bit more about how it's built? How your specific company is building it, as well as how it's kind of like done overall.
Sure. Yeah, I can touch on that. So we just have a sort of a simple energy app that integrates to the DOE2 database. So it is sort of similar to an eQuest or an Energy Plus in what it references in the background. But we have some other inputs that we adjust. Sultan, do you want to touch on that?
Yeah, sure. You can add inputs or variables, assumptions based on the building you're trying to analyze or run a load profile for, based on what windows you have, R values, let's say, what equipments you have. You can put a load schedule for each equipment. You can have multiple rooms, you can section that zone, have a warehouse, let's say, what type of equipment's in this warehouse. You have an office space, what type of HVAC you have, and so on. And you put all these load schedules, all these, small details for each single equipment you have. Then this will basically produce your 8760 load profile, summarizing your entire energy consumption or predicted energy consumption. And then, we try to confirm how close or how accurate is our 8760 after the fact of building these facilities, and try to get utility bills to compare and see where we fall within the assumptions we had.
Thanks, I appreciate that answer.
Yeah.
We have another question of how effective would integrated controls be in non-cannabis CEA greenhouses?
Yeah, that's a great question. So cannabis or non-cannabis, right? I think an integrated control system is going to hinge on what you're controlling, right? So if you have a complex HVAC system, an integrated control system would be great. If you're doing, a pad cooler with vent motors, you may not see as much benefit out of an integrated control system.
Thanks, Sam. That was very clear and concise. Looking real quick. So for PG&E, can you talk a little bit about kind of pushing electric generation towards gas within this kind of context, talking about combined heat and power? Is that something that PG&E feels favorably towards? Is it something that PG&E kind of views as like a temporary necessary evil? What kind of is the PG&E approach towards combined heat and power right now?
So,
Scott?
yes, while the state is definitely moving towards reducing the amount of natural gas we use, we're fully supporting a CHP as a great source to provide electricity and heat to some of your other operations. As Sultan showed, I think it was, it's a great opportunity for customers to use. So we're supporting it for the time being anyway.
And CHP does qualify under SGIP as generation. So if implemented in the most favorable manner, you'd be looking at a $4.50 incentive per watt.
Yeah, thanks. And kind of another question generally about the PG&E programs. There's been a couple of questions asked of like, do these actually apply to cannabis cultivators? Can cannabis cultivators actually take advantage of them? Because there is a bit of anxiety about programs that might be federally funded.
Yeah, and we're still working on that, to be honest. We have a white paper at the CPC right now, trying to open up the door a little bit more. We also have an extra hurdle that cannabis customers have to go through for ag rates. And we're doing our best to break these barriers down. I think we'll make good progress this year and open up the opportunities so it's a level playing field, that cannabis is not held to higher standards, and given the opportunities that non-cannabis customers are provided. So hopefully we'll see we'll see some success on those this year. TRC is a great resource on the questions about energy efficiency. I saw one on bill financing, and I think they're open to it, but I'm not sure. So reach out to whomever sent that. I think it was anonymous. Reach out to TRC to get the latest. And Carmen, I'm not sure. Do they have our contact information?
Yeah, you can drop your contact information in the chat to everyone, and they can get in contact directly with you.
Yeah, so if you have a question or you want me to follow up on any of those questions, I'd be happy to do so, and keep you informed.
Thanks, I really appreciate that.
I think I answered it.
Yeah, and keep the questions flowing, because we really do want to make sure that we're answering your questions and directing them towards your interests.
I'll jump on the market access.
Yeah.
The last question there. I believe we're looking at the next round starting up in 2024, about this time, maybe June. So while they're running out of funding, or I've heard they have run out of funding, one, I think there's a possibility of pulling in more funds for that program, but I've heard more likely it'll pick up again in 2024. Probably with some refinement to the program, but that's the latest that I heard.
So, but actually,
two weeks ago,
that does change over time. And I actually talked to the program manager yesterday, and more money is available right now, but really they encourage getting the applications in within the next few weeks to take advantage of that. But right now there is, and that's another place where you now have contact for the market access program, and you can contact them directly, or you can contact your account representative and say, I need some help navigating this. Help me, please.
Yeah, thanks. One that kind of goes to PG&E, and then maybe we'll ask our ARCO team kind of expanding past that. So we have a question about specific growers that are utilizing dimming or even turning off grow lights during demand events? Do you have any specific people that you can think of that are currently doing that activity?
You know, I wish I did, and I started typing a response to this 2 or 3 times. I'm new to the role, and I'm just meeting my new customers, so I can't speak to any that I have actually spoken to. And that's one of my goals in this role, is to start to develop that type of data set, so that other CEA customers can be familiar or know what their partners are doing. So I can't say I do, is the short answer.
Sam or Sultan, is there anyone you know of that you've been working with kind of nationwide?
Not specifically for demand response. I've seen some adjustments to light cycles from 12-hour to maybe 11.5 hours, just due to energy savings associated with that. Obviously, at your own risk, right? Be cognizant of your lighting and what you need to grow, but I have seen that.
Okay, cool. I'll move us on a little bit. And I know it's something that we talk about often. Like, we have growers that will talk about that as an option, whether or not they're specifically utilizing it currently. You know, I'm not sure, but we do have it, something that pops up as we talk across utilities kind of nationwide. It's something that does kind of come up repeatedly. So back to kind of more general questions. So probably for Sultan, I believe. So how does a producer evaluate if investing in renewable energy, say on-site solar, is the right solution for them? What are those kind of like key things that need to be hit?
In terms of solar, again, as I mentioned, you want to see if you're trying to, you know, in terms of an investment, you want to see what is your payback period. Does it make sense to pay, let's say, $1 million and then save on, let's say, around 200,000 every year? Does it make sense, you know, to get a payback period of 5 years? If that's the case, I would say, you know, solar makes sense to have it for your facility, right? It's basically producing energy, saving you money, adding an energy source to your building, reducing your demand from the utility. So I would say that's you know, a good way to start and a good way to choose solar. Another thing is, again, you want to make sure that your facility can, as I mentioned in the presentation, it can withstand that load added to your roof if it's a roof mount, right? Or if you have enough space, you can have a ground mount system. And you need to look, you know, to think about the holistic view of your solar system and where you want to place it in your building or in your facility, how you want to interconnect that. So if you check all these boxes, solar is a good solution.
Thanks, Sultan. And now we have a couple of CHP kind of questions that we wanted to talk about. So to start with combined heat and power, how big of an operation do you need to make it worthwhile investment?
Oh, that's a good question. Well, you know, combined heat and power, basically for high demand facilities, right? Manufacturing facilities, mostly something that is running 24/7. You know, because solar cannot take energy or cannot produce energy during the night. So having a CHP for a high demand facility, mostly manufacturing, greenhouses, indoor grow, all of these will be a good fit, right? You want to produce energy as much as possible. You want to offset most of your production, and so on. So that would be a good place where you want to have a CHP system.
And then within CHP, you know, there is a lot of potential to be able to use that CO2 within a grow operation. So, you know, obviously you can't just go directly and pump that in. What kind of equipment or activities have to happen? What kind of investment has to happen to be able to make that CO2 usable?
Right. So there's multiple ways. One main component is having a filter. You know, there's an exact, you know, method of adding these filters. It's more question to the manufacturer or the packagers of the CHP. But what does that do is filter your CO2 so it can be reusable for, or let's say food grade certified, where you can use it for your crop and have this CO2 use for your greenhouse or your indoor grow. Another thing is CO2 liquefaction, where you can use that CO2 or sell it somewhere, or you can store it and use it later on.
Thanks, Sultan. I appreciate that. It looks like we had a new question come in specifically about indoor grows. If lighting and the associated HVAC that are only used during lights on are about 80% of the load and not being enrolled in demand response programs, what is the value proposition to cultivators to participate in those demand response? So probably more towards, either Scott or towards the ARCRA team. So my initial response to this would say, especially with 12-hour lighting cycles, like a lot of cannabis, when you kind of time those things, even you can be, hitting different parts of that peak demand or demand response. You could even consider kind of shifting it throughout the year to kind of adjust around that type of demand response. Or if you're, looking at those demand response programs, you could potentially, like we said, take advantage of some dimming. There's been some really interesting research coming out recently about kind of the amount of light needed to keep plants active within that photo period without, necessarily having to like kind of a minimum lighting level. So, I don't know again how many people are currently doing this activity, but what we've been seeing is articles coming out of, oh, well, you can keep your lights at this level and it'll keep the plants active, but give them most of their light kind of on the shoulder sides or in the beginning, whichever part is kind of hitting your demand response. So I think there's a lot of ability for growers, especially cannabis growers with those 12-hour cycles to participate. But from your experience, is there, anyone that you've seen would be really, valuable? I know, Scott, you're pretty new, but maybe Sultan or Sam?
Sam, you want to take that one? Yeah, it's an interesting question, right?
Yeah. Hard to answer. I would say I'm not a grower, and
right, probably maybe we can follow up with a more educated answer for this one right after this this panel.
I think it's one of those things that people are excited about,
right,
but haven't necessarily taken advantage of yet. So I think if you look towards places like, say, the Cannabis Business Times or Greenhouse Grower, people might be able to find some articles that are specifying things like light levels that might be appropriate for that. I don't think that we've published anything related to this at this point, but a lot of it's kind of starting to come out of those research groups that are related to these different kind of cannabis products, because for a long time you couldn't research cannabis, and now we finally have some universities being able to do that type of research.
Sure. I mean, during light selection, right, working with a lighting manufacturer, they may provide you with a PPFD, or you may provide them, this is a target PPFD, right? So I think working with them to determine proper height of your light fixtures, right, leveraging the tool library that Mary had kind of shared, and maybe using a PAR sensor to make sure that your dim setting on your light is exactly where you need it to be, and you're not, too bright. That could, tuning and things like that may be methods of proving efficiency, but not aware of other things like that.
Yeah. Well, our last question on here is about greenhouse projects and educational material about these programs. So all this slide deck will be available after the course. So the recording will be available, the slide deck will be made available. All of that will be accessible, and there's links throughout so that those can kind of be explored. And then Resource Innovation Institute specifically has some best practices guides and things like that in our catalog. And I'm just dropping those links in the chat right now that can potentially kind of help people learn about how to continue to be more efficient. But if there's specific additional questions, feel free to email any of us that participated. So you can email me, you can email Mary. If any of the ARCRA team is comfortable, they can drop their emails in the chat as well. And are there any questions that you have for each other? I've run out of questions.
Before we go there, let me just remind everybody that the survey link is in the chat, So please do help us out by giving us your feedback. We really appreciate it. And
Oh, we got another question.
back to you.
One more question. So any research to show that a cooler temp might be paired with lower light to simplify slow growth without near full stop and then ramp back up again? I think that, so from our end, kind of, I guess I'll reflect a lot of the more grower specific conversations that we've had. There's been a lot of interesting research about substituting CO2 for light. So you could potentially do something like dim down your lights, but pump more CO2 in and get the same kind of growth rate just based on that. But not so much with temperature. I don't think that there's as much research going on with temperature. I think it's more about the amount of oxygen, lighting, and water kind of available and balancing all of those things. Plant empowerment has been a really interesting kind of philosophy that's not cannabis specific, but it is kind of a really good way of discussing kind of plant science and engineering and kind of resource consumption as it comes to kind of the flow of different resources through the plant. So not so much temperature, but definitely CO2 is something where there's some really interesting research coming out. So if you have a period of time of demand response, you could theoretically potentially dim down your lights, pump in more CO2, and respond in that capacity, because that CO2 can be liquefied and stored on site. Like, most cannabis producers already have a source of CO2 that they're pumping in, and they could just kind of balance those levels a bit. So it'd be worth checking out that type of research. And if there's no additional questions, I think we'll bring it to a close a little bit early. We appreciate all of your questions, your participation. Thank you so much to all of our panelists. Thank you to PG&E. We really appreciate the opportunity to share knowledge and to bring your expertise to PG&E's client base. So thanks so much and have a great day.